Did you know that the base 10 blocks that we commonly use in classrooms today date back to the 1960s? They were created by a Hungarian mathematician and educator called Deans, and he was a strong advocate for using concrete materials to teach concepts to young students. These specifically were used to teach place value and our base 10 number system, and they typically use units for the ones, a long for the tens, a flat for the hundreds, and a cube to represent thousands. In this episode, I'm going to show you how base 10 blocks have been used to teach the paper and pencil algorithm for subtraction and the common misconception they have created to millions of students the world over, and that probably means you. And if you hang around to the end, I'm going to show you a simple tool that you can use to fix that misconception, and it will change the way you think about numbers forever. First, let me say that I'm a big fan of base 10 materials. When used correctly, they help learners visualize and manipulate numbers, and they make operations more concrete. For example, suppose I want to add these two numbers. I can see 3 tens and 6 ones. I can also see 1 10 and 2 ones. So 36 add 12. We're taught to add the ones first, so I combine all these, I would count them, and I would see this 8 ones. I then add the tens, so I combine these. So I now have 4 tens and 8 ones, 48. If you want to subtract, you represent a total that we call the minuend, and we take away the parts of the other number that we call the subtrahend. For example, here we have the 4 tens and the 8 ones that we just calculated the total of a moment ago. So 4 tens, 8 ones. If I want to take away 12, I'll take away 1 10 and 2 ones. What is left is the answer, and we call that the difference. The problem arises when you don't have enough in any one place to take away the subtrahend. For example, if I wanted to take away 29, I don't have enough ones in this place, so I've got to do something to the tens to make this possible. Suppose you want to start with 315 and take away 283. Here I have 3 hundreds, 1 10, 5 ones. Where do we start? We've been trained to start in the ones place, even though there are more efficient ways of subtracting, but that's a topic for another episode. So how many ones do we have? We have 5 ones. Do we have enough ones to take away 3 ones? Yes, we do. So let's do that and record what we have left. Right, what do we do next? We do the tens. How many tens do we have? 1. Do we have enough tens to take away 8 tens? No, we don't. We have to regroup this into individual tens and put them over here. So ordinarily we would do that and record what we've done. But this is where the wheels fall off. There are simply too many steps and it becomes quite cumbersome. And this is essentially the misconception I was referring to. We're told to look at the number of blocks in the place. But I think there's an easier way of doing it, and this is the tool we use to fix the misconception. It's called a numeral expander. Here we have 315. If I pull it apart, you can see the place value names for the numeral. 3 hundreds, 1 10, 5 ones. This is called traditional place value partitioning, and is the way we've been trained to think about numbers. And it's important that we think about numbers like that when we need to complete the traditional paper and pencil algorithm. But the numeral expander can help us see numbers differently. I can also see 315 ones. You can picture 315 unit blocks if you like. I can also see 315. Now this is useful to help learn to read and write numbers. 315. In English, that's tough. We say the hundreds first, we say the 1 second, and we go back and say the teen part, the tens, last. So that could be quite difficult. So the numeral expander helps us read and write numbers as well. And I can also see 31 tens and 5 ones. Now I bet you, and certainly me, we were not taught to think about numbers that way. That is called non-traditional partitioning or non-traditional place value partitioning. Let's apply that thinking to the subtraction problem we just did. So we just finished subtracting the ones from our 315. Now we do the tens. How many tens do we really have? 31 tens. How many tens do we want to subtract? 28 tens. What is 31 subtract 28? It's 3. 3 tens. There is no need to regroup, and there's certainly no need for any more steps. It is as simple as that. So this is what I want you to do. Number one, forget about the way you were taught about numbers. If you went to school in the 70s, 80s or 90s, I suspect you were taught how to compute using traditional paper and pencil algorithms. But these are the skills of yesteryear. 2, use a tool such as a numeral expander to help students to think differently in numbers. For example, in thinking about 315, you don't just want them to think 3 hundreds, 110, 5 ones. You also want them to think 31 tens and 5 ones. And finally, if you've seen value in this episode, go ahead and subscribe today to make sure you never miss another learning moment with me. See you next time.